Alright, so today we're going to be looking at complex numbers and then getting towards polar coordinates. Okay, so first, let's remember the standard form for a the standard form for a complex number. So, our complex numbers are written in the form a plus bi. This is our real number part. This is our imaginary number part. So let's remember, this I is for imaginary numbers. This is not the I of vectors. Okay, so we're not thinking vectors right here. So let's talk about how we would graph an imaginary number. On our coordinate plane, our Cartesian coordinate plane, we have two axes, the x-axis and the y-axis. When we graph complex numbers, we also graph them on a rectangular plane. That's a lot like the x and y axis, but this is the real axis, and then this is the imaginary axis. And so if I were to graph the complex number a plus bi, I would go out a units on the real axis, and I would go up bi units on the imaginary axis, and that is where my point would be. These are axes. So the distance from the origin to here is a units, and the distance from here to here is b units. And so let's take a look at our right triangle. All right, there's a right triangle, a units, b units. And so we are going to convert this imaginary form into what's called trigonometric form, using what we already know about right triangle trigonometry. So we know this is a right triangle. We know that this side is the hypotenuse. We know that to find the hypotenuse, we do a squared plus b squared. Now that we're working with polar coordinates, this hypotenuse is going to get the variable r, and it's referred to as the modulus. Well, let's look at what r is. We know the relationship according to the Pythagorean theorem, right? We know that r squared is equal to a squared plus b squared. And so we can solve for r. And so we know r is going to be the square root of a squared plus b squared. And so that gives us this length here. The other piece of our puzzle is going to be this theta. And that's where we're going to use our right triangle trigonometry, right? Our SOHCAHTOA. And so we know that the sine of theta is equal to opposite over hypotenuse. So in this case, it's going to be b over r. And we know that the cosine of theta is adjacent over hypotenuse, so that's going to be a over r. And so then we can solve for b and a. So we would multiply both sides by r, and b would be equal to r sine theta. And then we would multiply here both sides by r, and a would be equal to r cosine theta. And then we can use all of this information to take a complex number that is in standard form and convert that complex number over to trigonometric form or polar form. So again, I'm going to start with the standard form here, which is a plus bi. And then I'm going to substitute these values for a and b. So a is r cosine theta plus b is r sine theta times I, because of our imaginary number part. So I'm going to place the I here for right now. But I'm only taking the sine of theta. I'm not taking the sine of the I part. So from here I'm going to factor out an r. And then what we typically do is we take the I and we multiply it in front of sine theta instead of being in the back side. So it's cosine theta plus I times sine theta. And so this is what is referred to as trigonometric form. Of our complex number. Alright, let's then also look at how we arrive at the value for theta. So again, if we think about what we did with vectors, we know that the tangent of theta is equal to opposite over adjacent. And so in this case, back to our right triangle, our opposite side is b and our adjacent side is a. So the tangent of theta is going to equal b over a. Alright, so for our skills for today involve us being able to find r and find theta and being able to take a standard form and write it in trigonometric form. And we're going to do all this stuff and then we're going to get to the really cool graphing part. But first we have to get just all these notations and things down. Alright, so here is our example. Write in trigonometric form. So if I have the complex number z, and we tend to use z for complex numbers here, that's just a common variable, 6 minus 6i. Alright, so our value for a is equal to 6. Our value for b, right, is negative 6. And so if I want to write that in trigonometric form, I need to find r and I need to find theta. So r is equal to the square root of a squared plus b squared. Remember, parentheses around your negative, which is then the square root of 72. And then we will simplify that radical. So 36 times 2 is 72. So that becomes a square root of 36 times 2, which is 6 times the square root of 2. So there's our value for r. Alright, next we need our value for theta. So we know that the tangent of theta is equal to b over a. And in this case, b is negative 6. and a is 6. And so the tangent of theta is equal to -1. So we go to our unit of circle. If the tangent of theta is -1, that's when sine and cosine have to be equivalent. So that's our force for our denominator. And tangent is negative in the second quadrant and the fourth quadrant. But let's go back to our complex number. It is 6 on the real axis and -6 on the imaginary. So that is going to the right and down. So this is our trig value, which is 7 pi over 4. So that's our value for theta. And so we put the pieces of the puzzle together, and we're going to take z and write it in its trigonometric form. And z will be equal to 6 times the square root of 2, because that's r, times the cosine of 7 pi over 4 plus the sine of 7 pi over 4. All right, hopefully you've got the hang of that. Let's try one more. Z is equal to -2 minus 2 times the square root of 3i. All right, I would like you to pause the video and see if you can find r and theta, and then come back and compare to what I've done. So when you substitute in a and b for r, and -2 squared is 4, and then -2 squared is 4, and the square root of 3 squared is 3, and 4 times 3 is 12. So then we get the square root of 16, which is 4. All right, then we're going to find our theta by using tangent. So tangent of theta is -2 square roots of 3 over -2. So then we're going to simplify, and we're going to get the square root of 3. And then we're going to refer to our unit circle. Tangent is positive in the first and third quadrants. And the square root of 3 is associated with the denominator of 3. And so 4 pi over 3 is going to be the one we want, because we're going negative on the real number axis, negative on the imaginary axis. So because this is negative, negative, here we have negative, negative. It simplifies to positive. But if it had been positive over positive, we would be here in the first quadrant at pi over 3. But since it's negative, negative, we're down here at 4 pi over 3 for theta. So then we're going to write that complex number in trigonometric form. Z is going to equal 4 times the cosine of 4 pi over 3 plus I. Oh, you know what? Let me go back on this example. I forgot my I. It's not a complex number if we don't have the imaginary part. I'm so sorry about that. I, sine of 7 pi over 4. And here we have 4 cosine 4 pi over 3 plus I times the sine of 4 pi over 3. All right, so we have taken a complex number in standard form and put it over into trigonometric form, or can also be called polar form. And now we're going to go the other way around, and you're going to love this because if you know your standard angles in trig, it is so super easy. Now we want to write in standard form. And so we're going to have z equals 8 times the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. So we're just evaluating this expression. So we've got 8. We know that the cosine of 2 pi over 3, 2 pi over 3 is in your second quadrant. Cosine is negative, so it's negative 1/2. Plus I times the sine at 2 pi over 3. Again, second quadrant angle. The sine is positive, square root of 3 over 2. So now we're just going to distribute the 8. So 8 times negative 1/2 is negative 4. 8 times the square root of 3 over 2 is 4 square roots of 3, I. Okay, so let's just review what we have done. We have identified these new values. Right? So we've got these new values that we're talking about, r and theta. And so we're going to be graphing in terms of r and theta instead of x and y. To find r, it's a form of the Pythagorean theorem. To find theta, we're going to use tangent. And with that knowledge, we are going to be able to start in complex number standard form and convert to trigonometric form with the r and the theta. And the other skill is we are going to be able to start in trigonometric form and convert to standard form. And that ends today's lesson, and now you are ready to practice on iExcel.